Hi, I'm Stefan, Senior Solutions Architect from AWS.
I'm Alex, Senior Software Engineer at Manchester Airports Group, and this is my architecture.
Hey Alex, this looks like a really interesting architecture. I see a lot of our AI services and also generative AI service on the map here. Tell us about the business problem that you're trying to solve with this architecture.
Yeah, so at Manchester Airports Group, we serve over 60 million passengers a year, including other customers, taxi drivers, people dropping off and picking up, etc. So the ask was to pull together information from many disparate data sources, whether that be map data in the airport, flight information, or other information on the website, into a single one-stop shop that's visible and present in the terminal buildings, which is the kiosk solution that we've come up with here.
Got it. So how do the customers interact with the system? So I think it's like passengers, taxi drivers, all people at the airport, right?
Yes, that's right, yes.
Okay, so walk us through a typical flow, typical question that the user would ask.
Yep, so let's take a question, for example, what time is my flight?
Right.
The first thing that will happen when the question is asked is the question goes to CloudFront, which is our content distribution service,
right,
and Firewall, which protects, obviously, the system from external requests.
And then the request lands into AWS, and I see an API gateway here. So how does it continue from there?
Right, yeah. So the question's routed through API gateway, and in the case of what time is my flight, it'll be routed through Translate and into the getAnswer function, which is a wrapper fundamentally around Bedrock, which is how we serve the answer from the LLM back to the user. Got
it. I see Translate here. That's interesting. Why do you put Translate here before the large language model? Because there are a lot of large language models which are supporting multi-language. So why do you do that?
Right. So two things. The first is that we're an international airport, so we serve international customers who speak almost every language on the planet. Large language models will only support generally a handful of languages in comparison.
Right.
So a major advantage of Translate is that it simply supports more languages than large language models.
Got it. And you also decouple, right? You have more flexibility than choosing the right large language model for your job, okay?
Exactly. It means that we can select the best model regardless of what language it supports. So if in the future we have a new, amazing, perfect model that comes along that only supports English, that's not a problem for us.
That's a very interesting pattern. Then I see here a lot of agent tools. So I suppose you're using Retrieval Augmented Generation, right? And you have one agent probably?
Yes.
Can you walk us through that setup?
So what happens is that our agent will use the tools which essentially represent the data sources. So you mentioned Retrieval Augmented Generation, or RAG. So we use Kendra to provide context from the websites to the large language model, as well as flight information from the API there. The reason we do that is that it's the same flight information that's on the website. So we'll never be in a situation where the website contradicts what comes out of the virtual assistant.
Okay, and by that you also implement the optimal user perspective or user experience, right?
Perfect.
Yeah. Got it. Okay, then on the top of the architecture, I see DynamoDB, the chat history, and also an archive. Maybe you also want to walk us through that flow.
Yes, we use Dynamo to capture insights about customer conversations.
Okay.
So when a customer asks a question, the question is stored in chat history and then is passed to our chat history archive.
Right.
The reason we do this is because customers are really open and candid with this because it's a virtual assistant and not a human. It gives a level of honesty that we might not otherwise have. So analysing that archived chat history gives us insights about potentially missing content from our data sources. So if the virtual assistant consistently can't answer a specific question, it points out that we need to do better and improve the system in certain areas. Additionally, customers can rate their conversation. They can give it a thumbs up and a thumbs down and a comment about how the virtual assistant has helped them, which is again stored in our archive, so we can improve the system in the future.
Yeah, got it. And it just gives you insights that you typically would not get from a human interaction, right?
Precisely.
Awesome. Thank you for sharing this architecture with us. It's really interesting how you use, generative AI to integrate those different data sources and provide an exceptional user experience to your customers. Thank you very much.